Namaste children. Today's assignment. Here are the questions. What is electric charge? What are the effects in regards to charge on both of the atoms when an electron is transferred from one neutral atom to another? What is the difference between electrical conductors and electrical insulators? What is the effect of quantity of electric field lines on the field strength? What is the symbol or unit for Coulomb's constant? List two of the four properties of conductors in electrostatic equilibrium. Draw the electric field lines of one of the following: a single charge, or two equal and opposite charges, or two equal like charges. What is the formula for Coulomb's law? Taking this into account, how does distance impact on electric force? Now, we will see the whole chapter till what we have learned at a glance. Flow of electrons and direct current in a circuit. Electrons flow from the negative terminal to the positive terminal. By convention, electric current flows from positive terminal to the negative terminal. How can electric current be expressed? Electric current is expressed as the rate of flow of charge through a conductor per unit time. That is, electric current I is equals to quantity of charge Q by time T. SI unit of electric current is ampere and is designated by capital A, and 1 ampere is equals to 1 coulomb per 1 second. Electric current is measured by ammeter. What is an ammeter? Ammeter is a device that measures the current flowing through any conducting material. It is connected in series to the conducting material since it has low resistance. What is electrical potential and potential difference? Electric potential is the capability of bringing a charge from infinity to the required point is also known as electric potential. What is electric potential difference? Electric potential difference is the work done to bring unit positive charge from one point of the conductor to another. That is, potential difference V is equals to work done by charge mathematically. So since V is potential difference, W is work done, and Q is charge, V is equals to W by Q. The SI unit of potential difference is voltage and is measured by voltmeter. Electric potential is the amount of work done in bringing a unit positive charge from infinity to the given point in the electric field. It's a scalar quantity. Its SI unit is joules per coulomb or volts. What is potential difference? It's the amount of work done in bringing a unit positive charge from one point to another point in an electric field. It is also a scalar quantity. Its SI unit is joule per coulomb or volts. It is responsible for the flow of current in a conductor, measured by a device known as voltmeter. In detail, electric current will flow through a conductor only if there is a difference in the electric potential between the two ends of the conductor. This difference in electric potential between the two ends of a conductor is called potential difference. The potential circuit is provided by a cell or a battery. The chemical reaction in the cell produces a potential difference between the two terminals and sets the electrons in motion and produces electric current in the conductor. Potential difference between 2 points A and B of a conductor is the amount of work done to move a unit positive charge from A to B. Potential difference mathematically is equals to work done by charge, or V is equals to W by Q, since potential difference is designated by V and work done by W and charge by Q respectively. The SI unit of potential difference is volt. 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. Therefore, 1 volt is equals to 1 joule per 1 coulomb, or 1 V is equals to 1 J by 1 C. Potential difference is measured by a voltmeter. It is always connected in parallel across the 2 points between which the potential difference is to be measured. Why is potential difference important? Electric current will flow through a conductor only if there is a difference in the electric potential between the two ends of the conductor. The potential difference in a circuit is provided by a cell or a battery. The chemical reaction in the cell produces a potential difference between the two terminals and sets the electrons in motion and produces electric current. This is the reason why potential difference is important, to set the electrons in motion in order to produce electric current in a conductor. Now, what is voltmeter? Voltmeter is a device that measures the potential difference across the ends of any conducting material. It's connected in parallel to the ends of the conducting material since it has a high resistance device. An electric circuit. Electric circuit is a continuous and closed path of an electric current. A schematic diagram of an electric circuit comprising a cell, electric bulb, ammeter and a plug key is known as circuit diagram. Once again, electric circuit is a continuous and closed path of an electric current. A schematic diagram of an electric circuit comprising of a cell, electric bulb, ammeter and a plug key. These are the symbols of components used in electric circuit. The long line represents positive, small line represents negative of an electric cell. A battery is a combination of cells. A plug key or switch open, a plug key or switch closed. Closed plug key will have a dot in the middle. Electric bulb, a resistance, a resistor of resistance R, that means a constant resistance, a variable resistance or a rheostat, ammeter, current measuring device in a circuit, potential difference measuring device in a circuit, a wire joint, a wire crossing over without joining. Some other electrical symbols. The first one is a schematic diagram of electric circuit with switch open, constant resistance, a cell and a bulb or a globe. Cells in series, 6 cells in series, it's a battery. Then wire or a conductor or a connecting cable. Next, single resistor, 2 resistors in series, followed by wire crossing, not connected. Then 2 cells in parallel, then 3 cells in parallel, positive, negative symbols, earthing, wire crossing, it's connected. Then a capacitor, filament lamp or torch globe or light bulb, 2 resistors in parallel, 3 resistors in parallel, winding of soft iron core, that is electromagnet, then switch open or plug key open, a variable resistor or rheostat, then a fuse, different types of fuses, a variable power supply, an ammeter, a voltmeter, a voltameter and a galvanometer with shunt. Components: connecting wire, a lamp or light bulb or globe, a battery, a switch open, electric motor with M in the middle, resistor, ammeter, voltmeter, electric bulb, switch, cell, battery, lamp, voltmeter, ammeter, resistor, variable resistor, and motor. Ohm's law. George Simon Ohm. He has the person given the relation between potential difference and current flowing in a circuit. It states that a constant physical condition like temperature and pressure are kept at constant, then the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. That is, I is directly proportional to V. V is equals to IR, where R is the constant called resistance. According to this law, conductors are divided into two: ohmic conductors and non-ohmic conductors. Ohmic conductors are those conductors which follow Ohm's law, whereas non-ohmic conductors do not follow Ohm's law. Once again, Ohm's law is a relationship between potential difference across the conductor and the current flowing through it. It states that the current flowing through a conductor is directly proportional to the potential difference between its ends, provided the physical conditions like temperature and pressure remains constant. That is, I is directly proportional to V, or V is directly proportional to I, or V by I is equals to a constant, or V by I is equals to R, where R is a constant called resistance for a given metallic wire at a given temperature. The given below is the verification of Ohm's law, the circuit diagram, which contains a battery, a conductor, a variable resistor and a constant resistor. To the constant resistor, a voltmeter is connected in parallel, ammeter and a plug key. While verifying Ohm's law, you will be connecting a nichrome wire AB in the circuit. For verifying Ohm's law, set up the circuit diagram like this, and first use one cell and note the current I in the ammeter and the potential difference V in the voltmeter across the nichrome wire AB. Repeat by using 2 cells, then 3 cells, and then 4 cells, and note the readings of the ammeter and voltmeter in all the cases respectively. Then plot a graph between the current I and potential difference V. The graph will be a straight line. This shows that the current flowing through a conductor is directly proportional to the potential difference across its ends. I is directly proportional to V, or V is directly proportional to I, or V by I is equals to R, where R is a constant called resistance of the conductor. And when we are plotting a graph in between current versus potential difference, a straight line is formed, and thus the graph is known as ohmic graph. Once again, Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference between its ends, provided all the physical conditions remain constant. That is, I is directly proportional to V, or V by I is equals to a constant, or V by I is equals to R. Here the constant R stands for resistance for a given conductor or wire at a given temperature. After doing the verification of Ohm's law experimentally, when we plot graphs, that is IV graph, by taking V on the x-axis and I on the y-axis, if the graph plotted is a straight line, it is called as ohmic graph, and if it is not straight line, it's called as non-ohmic graph. How we have discussed in mechanics the frictional force, same way resistance is the hindrance or obstruction for the flow of electrons or charges in a conductor. That is, it is defined as the hindrance to the flow of current. It is the ratio of potential difference to the current, that is R is equals to V by I. The SI unit is volts per ampere or ohm, denoted by symbol ohm. Reciprocal of resistance is called as conductance and it is designated by C. The SI unit is ohm inverse. So below circuits are showing high resistance and low current, and the second diagram is low resistance and high current. How can we say this is high resistance and low current, low resistance and high current? By seeing the diagram? Is it by basing the color? No, the thickness of the wire. If the thickness of the wire is more, it will provide low resistance and high current flow will be there. If the wire is thin or conductor is thin, resistance offered is high, so current flow will be low. Once again, what is resistance? Resistance is the property of a conductor to resist the flow of electrons through it. According to Ohm's law, R is equals to V by I. The SI unit of resistance is ohm. If the potential difference around the two ends of the wire is 1 volt and the current flowing through the wire is 1 ampere, then the resistance of the wire is said to be 1 ohm. Again, resistance is the property of a conductor to resist the flow of the current through it. According to Ohm's law, R is equals to V by I. The SI unit of resistance is ohm. If the potential difference across two ends of a wire is 1 volt and the current flowing through it is 1 ampere, then the resistance R of the conductor is 1 ohm. Since I is equals to V by R, the current flowing through a resistor is inversely proportional to the resistance. So, if the resistance is doubled, then the current gets halved. What are the factors affecting resistance? The factors affecting resistance are length of the conductor, area of the cross section, the temperature, the material with which it is made up of. Once again, what are the factors affecting resistance? The factors affecting resistance are length of the conductor, area of the cross section of the conductor, and the material with which it is made up of, and the temperature. Resistance is directly proportional to the length. That means if the length of the conductor increases, the resistance also increases. And resistance is inversely proportional to the area of conductor, the cross section area of the conductor. That is, if the area of cross section of the conductor is increasing, resistance will decrease. That means if the thickness of wire is increasing, then the resistance decreases. From equation 1 and 2, we get R is directly proportional to L by A, or R is equals to rho L by A, where rho is constant and it is called as specific resistance or resistivity of the conductor. What are the factors affecting resistance? The factors on which resistance depends. Resistance of a conductor is directly proportional to the length of the wire and is inversely proportional to the area of cross section of the wire, dependent on the material of the conductor, directly proportional to the temperature of the material. That is, R is directly proportional to L, R is directly proportional to 1 by A, R is directly proportional to L by A, R is equals to rho L by A. Here, rho is constant proportionality and is called as resistivity or specific resistance of the material of the conductor. The SI unit is ohm meter. Factors on which the resistance of a conductor depends upon. The resistance of a conductor depends upon its length, area of cross section, material of the conductor. Resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section of the conductor. R is directly proportional to L. R is directly proportional to 1 by A. R is directly proportional to L by A. R is equals to rho L by A, where rho is a constant proportionality called resistivity or specific resistance of the material of the conductor. The SI unit of resistivity is ohm meter. Conductors like metals and alloys have low resistivity, that is 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter, whereas insulators like rubber, glass, etc. have high resistivity, that is 10 to the power of 12 ohm meters to 10 to the power of 17 ohm meters. Now, what do you mean by specific resistance? Specific resistance is the resistance of a conductor of unit length and unit cross-sectional area. That is, if length is 1 meter and area is 1 meter square, then R is equals to rho. It depends upon only on the material of the conductor and denoted by rho. SI unit is ohm meter. Rho is directly proportional to the temperature of the conductor, also known as resistivity. Resistivity of substances. Conductors like metals and alloys have low resistivity of which is equivalent to 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. Insulators like rubber, glass, etc. have high resistivity which ranges 10 to the power of, which is like 10 to the power of 12 ohm meter to 10 to the power of 17 ohm meters. Substances with low resistivity are better conductors of electricity than those with high resistivity. Is called as resistivity table. When you observe which will have the least value, that is very good conductor or best conductor. When you see in this resistivity table, silver is the best conductor of electricity.